explain. Good morning or good afternoon, everyone, depending on where you're at. My name is Mark Kopko. I'm the Advanced Vehicle Technology Manager for the Pennsylvania Department of Transportation. So everything that relates to connected automated vehicles falls underneath me. So today I'm going to do a two-part presentation. The first part is basically going over what we've done in Pennsylvania, some lessons learned, and what we have coming down the pike. And then the second part is to talk about the proposed Connected Fleet Challenge, which is designed to be a follow-up to the SPAT Challenge. So in Pennsylvania, we've been working in the connected vehicle realm for several years. This map just gives you an overview of current initiatives and planned. So high level, we have roughly 54 connected intersections throughout the state. In the next 5 years, we have an additional roughly 210 planned for deployment. Predominantly, they're located in the Pittsburgh region, in the city and neighboring suburbs, but we also have deployments in Harrisburg and then planned deployments in the Philadelphia region. So with the planned deployments, and to give you an idea of the existing, so in Pittsburgh, predominantly along the smart spine system of the city, so that would be the routes that are highlighted in blue. So we have existing signals in the western part of the city, but going forward by 2022, we expect to have an additional 45 to 75 connected signals along those blue corridors on this map. In the Philadelphia region, we'll have an additional 160 connected intersections that will be happening on the pink routes that are basically running parallel to the I-76 Schuylkill Expressway. This is part of a larger active corridor management program. We also are creating a testing facility in partnership with the Pennsylvania Turnpike and Penn State University. So within this facility, we'll also have some simulated signalized intersections. So it'll be 4 signalized intersections in this facility. Plus, we'll be deploying roadside units for curb speed warnings, rail grade crossings, tying into tolling applications. We'll have a laboratory setting. We'll be using RSUs and OBUs in a controlled setting for interoperability testing and then just initial testing of applications before we roll out to a live environment now that we have a location that can be controlled testing. And we're going to try and be communication agnostic on this facility. So we'll be looking at DSRC and any type of other communication spectrum. So this facility will be opening up by 2022. But the big thing that we wanted to talk to about our existing deployments, we wanted to highlight our Harrisburg deployment. To give you some background, we wanted to do a demonstration back in 2016 for members of our legislature or state legislature to give them an understanding of connected automated vehicles. So Carnegie Mellon brought up their automated vehicle to the Capitol and was going to give rides to roughly about 50 members of the General Assembly around the Capitol complex. However, we wanted to make sure that safety was of the utmost, so to allow for redundancy, we equipped the signalized intersection so that you would have that extra communications with the automated vehicle. It wasn't necessary, but it's just there that it just makes everyone more comfortable. It's something CMU wanted, and it's something that we agreed upon. The other nice thing about this is since our office is located right next to the Capitol, our central offices gives us an area where we actually have a proving ground, a test bed right outside our door. We don't have to go out to the Pittsburgh region or Philadelphia in the future to test anything. We have something right outside. So it just gave us a great opportunity, and we thought this would be something to use and to build off of. So one of the unique things about our deployment, to the best of our knowledge, it's still the fastest deployment from concept to actual deployment done by a public agency. So we did it, had it all up and operational from the time we basically wrote it on a whiteboard, throwing concept out there to see if it would stick, to actually having something in the field deployed in 8 weeks. So this just gives you an idea of the timeline. We started in August of 2016, brought people on board to do basic ConOps, field view, start getting quotes. We had a kickoff meeting, purchased the units. They arrived 2 weeks later. We had to do some modifications to the traffic controllers. We did testing, and then by week 9, everything was in place after those initial tests, and we were doing demonstrations for the governor and key members of the General Assembly. So this just gives you an idea of the partners that were involved. So we worked with RADA, Lear now, uh, for the actual roadside units. The vehicle that Carnegie Mellon brought out had a RADA onboard unit, so it just worked out just to make sure you had interoperability between. We also worked with the city, the university, and then you can see the suppliers, the traffic control manufacturer, the consulting firms that helped out. So this map will show you basically where the signalized intersections were equipped. So there's 8 of them all around the Capitol complex. So the Capitol is right by the staging area that's signed off. And basically for these demonstrations, we did a clockwise loop around the Capitol complex. So one of the things that we had to quick deal with is just ownership issues. Although the city didn't, or although the DOT didn't necessarily own any of the signals, some were actually on state routes, some were on city routes, and then some were actually owned by the Department of General Services. So that was something that we didn't really initially think about, just how to start bringing groups outside of, transportation realm when you start to get into the Department of General Services, because they control the Capitol complex. So just quick getting stakeholder meetings on board, getting them all up to speed on what we were actually doing, what does that entail, what has to be in place to make it work. That was an interesting concept. To give you an idea about the signals, as I mentioned, the city owns all the signals. They were upgraded to brand new McCain ATC-X controllers. However, we still had to do some firmware upgrades on top of that. All the roadside units were RADAs. At the time, we didn't have any fiber backhaul. That was recently just put in place here, so it was twisted pair. So we didn't have a communications back to a central location, so we had to keep going out to individual controllers and making any changes we needed to do or verify everything was operational. We couldn't do anything remotely. And that ended up being a struggle because we were constantly just moving around, especially for demonstration purposes, making sure everything was operational. Since then, we do have fiber backhaul in place, and now we are working towards integrating that back into our actual command and control systems and existing networks. From the deployment side, a big help was working with CMU, since they've done work with connected deployments, with RSU placements. We also had a contractor that had some experience in radio frequency expertise, so they helped us determine the best optimal placement based off the routes that we were doing to get the most out of the actual roadside units. We did all the configuration as much as we could before we put everything in place, just to save time. And initially, we didn't have any map messages. We didn't have time to go out and survey everything. So everything was actually integrated into the CMU automated vehicle. So that's where all the map messages were being controlled. So they had everything LiDAR mapped out pre-demonstration, and then we just had to start tying in the actual SPAT message into specific lanes and signal states in that way. So some of the lessons learned at the time, this predates the SPAT challenge, but we thought this would be more of a simplistic process. We thought, hey, this equipment, we've been talking about it for years. It's probably just sitting on shelves. We only need 8 of them. That shouldn't be a problem. Let's just quick order some. We didn't have much time to get something set up. And we were shocked to find out that most of the equipment manufacturers were requiring a 3-month plus lead time. Luckily, because of some partnerships that Carnegie Mellon had with RADA Lear at the time, they were able to fast track some development and have one of their plants make some roadside units rushed the actual production for us and shipped it over. So that's how we got that in roughly the 2.5-week timetable. Consultant support at the time, and it's still not there, but it was a struggle. It's still new to everyone. Everyone's learning as they go. So that's something that was just trying to find anyone that had some experience with this to help out, just to move things along. Procurement was an issue. We didn't have proper procurement documents in place. We were just using at the time it was the 4.1 specification, or the 4.0 specification. We didn't have time to go through an RFP process. So what we were able to do is we found out that RADA, CODA, and I believe one other manufacturer are actually on an existing contract, IT contract that we could access them through. So since we were spending under a certain threshold, we were actually allowed to using a purchase card to just do a PO right off that. So we were not lucked out for us just because of the small quantity. That's how we were able to handle our procurement. When we started working with some of these vendors to do the procurement, that was tricky because they didn't realize what we were actually asking for. It was still new to them. They didn't understand exactly what a roadside unit was or the function of it. We thought just because we had brand new McCain controllers in place that's all we need to do. We talked to them and they said that that they could convert things into the J2735. What we didn't realize is you needed to have firmware upgrades on top of that. So we had to work directly with the manufacturers to get everything done. We found out that coordination is key and critical. If it wasn't for the fact that everyone's willing to hop on almost daily phone calls to make sure everything was on the same page. Arada was writing custom code for us to help out. So was McCain at the time. We wouldn't have been able to do everything as fast as we could. Radio positioning, we didn't take that into account when we were first planning this out until we started talking to some of the contractors in CMU, trying to figure out the best positioning for everything. And then just lack of documentation, something that we're happy to see the SPAT challenges really started to address since we did our initial take at this. It basically was non-existent at the time, so you still had to basically make things up as you went, which was a great thing to see the SPAT challenge then build off of, and then to take that to the next step is what we want